Hello children, welcome back. So in the previous class we discussed about some strategies to figure out what are the roots of a quadratic equation without actually solving the given quadratic equation. So that was in ax square plus bx plus c is equal to 0, if the value of a plus b plus c is equal to 0, then the roots are x is equal to 1 comma c divided by a. This is what we discussed in the previous class. Now let us continue with these strategies. Suppose in this quadratic equation ax square plus bx plus c is equal to 0. Suppose instead of a plus b plus c is equal to 0, if a minus b plus c is equal to 0, then what will be the roots of the given quadratic equation? So in the same way, however you found out the roots of quadratic equation under a plus b plus c is equal to 0, in the same way we can show that and we can derive the roots of the quadratic equation are x is equal to minus 1 comma minus c by a, right? So if you want to prove this like how we proved in the previous class, we can do the same thing, so that we will get the roots x is equal to minus 1 comma minus c by a. For example, you are given a quadratic equation like x square minus 73x plus 73x plus 72 is equal to 0. This is one of the quadratic equations. So if you once observe x square plus 73x plus 72 is equal to 0 and compare this with the standard form ax square plus bx plus c is equal to 0, and then find out a minus b plus c. Here a is equal to coefficient of x square, that is 1, minus b is equal to 73 plus c is equal to 72. So when you add up 1 minus 73 and plus 72, 1 plus 72 is equal to 73 minus 73 is going to be 0. Therefore the roots of x square plus 73x plus 72 is equal to 0 are, what are those roots? X is equal to minus 1 comma minus c by a, that is minus 1 comma minus, the value of c is going to be 72 divided by a is going to be 1. So which is equal to minus 1 comma minus 72 are the roots of the given quadratic equation. So like that, by using these strategies we can easily figure out the roots of the given quadratic equation under these two conditions. These two conditions must be provided, right? So if these two conditions are there, if the given quadratic equation satisfied by these two conditions, then easily we figure out the roots by using x is equal to 1 comma c by a if a plus b plus c is equal to 0, and x is equal to minus 1 comma minus c by a when x is equal, when a minus b plus c is equal to 0. Hope you understand. So I think really you enjoy with these two strategies. Easily we can figure out the roots of quadratic equation without performing any calculations. So we'll move on to the next level of this quadratic equation, and just let us think about the quadratic equation like three quadratic equations I am taking here. The first quadratic equation is x square minus 5x plus 6 is equal to 0 is one quadratic equation, and second quadratic equation is x square minus 4x plus 4 is equal to 0, and third quadratic equation is going to be x square plus x plus 1 is equal to 0. These three are three different quadratic equations. So what are we going to discuss here now is, in these three given quadratic equations, either by using splitting middle term method, otherwise by using quadratic formula, otherwise by using completing square method, or by using any of our algebraic methods, you can easily figure out the roots of these quadratic equations. But beforehand, I just want to know, without actually performing calculations, without actually finding the roots, I just want to know about the nature of the roots of quadratic equations. What do you mean by nature of the roots of quadratic equation? See, here we have two kinds of numbers. Those two kinds of numbers are, first kind of numbers are real numbers and second kind of numbers are complex numbers, right? Which kind of numbers are said to be real numbers, which kind of numbers are said to be complex numbers, you are pretty much aware of all this. But coming to these real numbers, real numbers are categorized into three categories. They are based on 0, the numbers which are below 0 are negative numbers, and the numbers which are above 0 are said to be positive numbers. The numbers which below 0 are said to be less than 0 numbers, means the negative numbers are said to be less than 0 numbers, and the numbers from 0 towards right above 0, they are said to be greater than 0 numbers, right? So every real number can be either 0 or negative number or positive number, correct? So here if you find out the roots of these three quadratic equation, first of all I just want to know whether my roots of the given quadratic equation are basically the real roots or non-real roots. Non-real roots are nothing but it's a complex root. So how do I figure out without actually performing calculations, without actually finding the roots by any of our algebraic methods? Then I will have to think about it. So when I think about it, I will just understand what is my quadratic formula. So my quadratic formula is, what is quadratic formula? We just now discussed and derived that quadratic formula, right? So the quadratic formula for finding the roots of quadratic equation is x is equal to minus b plus or minus square root b square minus 4ac whole divided by 2a, right? This is the quadratic formula. And moreover, just now we discussed about real numbers and non-real numbers, which are complex numbers. When a number is said to be a real number, and what kind of numbers are real numbers? See, real numbers are of two types. Those two types are rational numbers and irrational numbers. Rational numbers, irrational numbers together constitute real numbers. So if a number is non-real, then it is said to be a complex number. And coming to rational numbers as well as irrational numbers, you already learned about what kind of numbers are rationals and what kind of numbers are irrational numbers. So irrational numbers are basically inside the square roots, either it is a square root or cube root or third root, whatever it is, right? So if the square root number containing any number inside it as a negative number, means the value of the radicand is negative, and moreover if this is second ordered surd, then this number is considered as an imaginary number. Of course we discussed this thing also in the previous class, like the number which is root over negative 36. For example, you cannot write this root over negative 36 as negative 6, because square root negative 36 is nothing but square of one particular number is going to be negative 36. But square of which number is negative 36? Is the square of any real number negative? It's not possible. So that is why square of no real number is negative. That is why square root of 36 can be treated as an imaginary number. So there is only one case here we need to understand, that according to the definition of ax square plus bx plus c is equal to 0, being a real quadratic polynomial where coefficient of x square, coefficient of x and constants being real numbers, since it is being a real quadratic equation. So where a, b, c are real numbers, so that here b is a real number, 2a is also a real number, there is a chance only for b square minus 4ac. It can be either positive value, or it can be either negative value, or it can be even 0 also. For example, what happens when that b square minus 4ac is positive, and what happens when b square minus 4ac is negative, and what happens when b square minus 4ac is equal to 0? Let us think about that. Okay, so I have taken three different quadratic equations here. One is x square minus 5x plus 6 equal to 0, and one is x square minus 4x plus 4 equal to 0, and one is x square plus x plus 1 equal to 0. See, my nature of the given quadratic equation does not depend on the value of b and does not depend on the value of a. That depends on the value of only the term inside the square root, that is what called radicand. So the nature of the roots depends on the value of only the radicand. That radicand here is b square minus 4ac. So I can say now clearly that nature of the roots of any quadratic equation depends on the value of b square minus 4ac. So that is why that b square minus 4ac, the value b square minus 4ac is called discriminant. So what do you call that? Discriminant of quadratic equation. So what is meant by discriminant? Discriminant is the value of a term b square minus 4ac which is inside the square root, that is b square minus 4ac inside the square root is square root b square minus 4ac or b square minus 4ac under square root is said to be discriminant of quadratic equation. So if the value of b square minus 4ac is positive, then what is the nature of the roots? If b square minus 4ac is negative, then what is the nature of the roots? If b square minus 4ac is equal to 0, then what is the nature of the roots? Let us try to understand now. Okay, I have taken 3 examples here. So those 3 examples will explain you now what exactly the meaning of nature of the roots of quadratic equation. So the first equation is going to be x square minus 5x plus 6 is equal to 0. Now finding the value of b square minus 4ac, and the value of b here is minus 5. So minus 5 whole square minus 4 times a into c. A is going to be 1 and c is going to be 6. So minus 5 whole square is equal to 25 minus 4 6 are 24 is equal to 1. Since it is inside the square root, so this is inside the square root, so this is inside the square root. Square root over 1 is equal to 1, or it is purely a rational number. Sorry, it is purely an irrational number. So irrational number is a part of real number. So it doesn't matter. Now here I will get the roots are real numbers only. But in our formula we have plus or minus. So that here minus b plus or minus square root b square minus 4ac whole divided by 2a will become minus b is equal to minus 5 plus or minus square root, just now we found b square minus 4ac, that is root over 1 divided by 2 into a is equal to, of course it is 1. So it is going to be minus of minus 5 is equal to plus 5 plus or minus square root 1 is equal to 1 divided by 2. So when you apply plus as well as minus for getting 2 roots, then the values of x are, when you use plus, then it is going to be 5 plus 1 6 divided by 2 is equal to 3, and the other root is 5 minus 1 is equal to 4 divided by 2 is equal to 2. See, 3 and 2. What kind of numbers these are? These 2 numbers are purely real numbers, as well as of course 3 and 2 are not same numbers. So 3 and 2 are different numbers. So that I can say for this quadratic equation, without actually finding the roots, what kind of roots that x square minus 5x plus 6 equal to 0 has? It has the roots, both are real as well as they are not equal. So I can say that if the value of b square minus 4ac, see here what we get here is 1. 1 means it's a positive number, right? Every positive number can be considered as greater than 0 numbers. So b square minus 4ac is greater than 0, or b square minus 4ac is positive, then the roots of that quadratic equation are said to be real and unequal, otherwise real and different, otherwise real and distinct. Okay, you can call with any name, like they are real and unequal, otherwise real and distinct, otherwise real and different, only under the condition that b square minus 4ac is positive, otherwise greater than 0, right? For example, I am taking one more equation, one more quadratic equation. So that one more quadratic equation is like x square minus 4x plus 4 equals to 0, right? I am going to find out the value of b square minus 4ac. The value of b is equal to negative 4, so negative 4 whole square minus 4 into a is going to be 1 and c is going to be 4. Minus 4 whole square is equal to 16, minus 4 times 4 equal to 16, 16 minus 16 is equal to 0. So what is this 0 for? This is the value of b square minus 4ac. Therefore, what are my roots? X is equal to minus b plus or minus square root b square minus 4ac whole divided by 2a will become minus b is negative 4 plus or minus square root, here we got the value of b square minus 4ac is equal to 0, right, which is 0. So 0 whole divided by 2a is 2 into a is equal to 1, right, which is minus of minus 4 equal to 4 plus or minus square root 0 is going to be 0 divided by 4, 2 into 1 equal to 2. See, either it is 4 plus 0 or 4 minus 0 doesn't make any difference. So it is going to be 4 divided by 2 as well as 4 divided by 2. 4 divided by 2 is equal to 2. Again 4 divided by 2 equal to 2. What kind of numbers these two are? Of course these two numbers are real numbers as well as 2 and 2. Can we say them they are equal? Yes. So 2 comma 2 are equal as well as real numbers. So with this example we can understand one thing, that the value of b square minus 4ac is 0. If the value of b square minus 4ac is equal to 0, then the roots are real as well as equal, right. So that's all about b square minus 4ac is equal to 0. Now with the help of that first example, we discussed and concluded that if b square minus 4ac value is positive, means greater than 0, then what kind of roots they are? They are real as well as unequal. And with this example, b square minus 4ac is exactly 0, then what kind of roots we got here? Those two roots are real as well as equal. Now we have greater than 0 numbers as well as we have equal to 0 numbers, and there is one more kind of numbers. What are one more kind of numbers? They are the numbers which are less than 0 numbers. So what are the numbers which are less than 0? They are called negative numbers. For example, my quadratic equation is x square plus x plus 5 is equal to 0, right. So if this is a quadratic equation, I am going to figure out the value of b square minus 4ac. So b square minus 4ac is going to be, b is equal to, that is x, it means 1 into x, because 1 into x only equal to x. So that is why b square is 1 square minus 4 times a is going to be 1 and c is going to be 5, which is equal to 1 square is 1 minus 4 into 1 into 5 equal to 4 5s are 20, which is equal to negative 19. Since this negative 19 is inside the square root, because in our formula we have minus b plus or minus square root b square minus 4ac, so that it should be inside the square root. See, this is the negative number which is there inside the square root. Can you consider this number as a real number? No, we cannot. Then this number does not belong to a real number. If a number is not a real number, of course you can call it as a complex number or an imaginary number, right. So which is equal to, and what is the value of root over negative 19? We had a discussion, right. We write it as negative 1 into root over negative 1 into 19. Root over negative 1 has a specific value, that is I into root over 19 is 19. So this is a complex number, right. So in this case, when 1 minus 20 is equal to minus 19 is less than 0, because it's a negative number. What is that negative number for? That is the negative number for b square minus 4ac. So if the value of b square minus 4ac is any negative number means which is a less than 0 number, then the roots of that quadratic equation are said to be non-real. Okay, non-real, or which are not real numbers or complex numbers, you can call it as, according to your standard you can call them are imaginary numbers also. And moreover, whether they are equal imaginary numbers or unequal imaginary numbers, of course they are unequal, because before this you have minus b plus or minus, right, minus b plus or minus root over b square minus 4ac whole divided by 2a, right. So here when you use 1 plus, you will get one imaginary number or one complex number. When you use minus, you will get one more complex number. So that these two complex numbers are different complex numbers, as well as they are of course complex numbers, means they are non-real numbers. Therefore we can conclude that if the value of b square minus 4ac is negative, then the roots are going to be non-real and distinct. Distinct means different real roots. Okay. So now I am going to conclude about the nature of the roots of quadratic equation. Please listen to me carefully. The nature of the roots of quadratic equation depends on the value of b square minus 4ac. That is why b square minus 4ac for ax square plus bx plus c equal to 0 is said to be discriminant of quadratic equation. So discriminant decides the nature of the roots of given quadratic equation. And moreover, if the value of the discriminant means b square minus 4ac is positive, then the roots are going to be real and distinct, means different roots. If the value of b square minus 4ac is equal to 0, then the roots are real as well as equal roots. Similarly, as we discussed earlier, if the value of b square minus 4ac is negative or less than 0, then the roots are going to be non-real roots. We can call them as complex roots as well as they are distinct roots. I will just summarize all of them. Just have a look. Depends on the nature of the roots of quadratic equation. Okay. So when I write nature of the roots, of quadratic equation depends on the value of b square minus 4ac. So that is why this b square minus 4ac is said to be the discriminant of quadratic equation ax square plus bx plus c equal to 0. So why am I telling for ax square plus bx plus c equal to 0? Suppose if you change the quadratic equation to some px square plus qx plus r equal to 0, then you cannot call the discriminant of px square plus qx plus r equal to 0 as b square minus 4ac. Then you should say it as q square minus 4pr. Like you can compare with the standard form of quadratic equation, whatever the quadratic equation you consider, right? And depends on the value of b square minus 4ac and is indicated by, there is a special indication for the discriminant that is called delta, and sometimes you can indicate that by using a capital letter D also. So D stands for discriminant and the special symbol for discriminant is delta. Now if the value of delta is equal to b square minus 4ac is positive number, means what? Which is greater than 0 numbers, then the roots are, what kind of roots they are? Then the roots are real and unequal. Unequal means they are distinct or different roots. Okay. Suppose if the value of delta is equal to b square minus 4ac which is equal to 0, then what do you call those roots? Then the roots are real as well as equal roots, right? And finally, if the value of delta is equal to b square minus 4ac is negative means what? The numbers which are less than 0, then what do you call the roots? Then the roots are non-real or complex roots, non-real and distinct roots. Okay. So this is about the nature of roots of quadratic equation. So with the help of this information, you can easily figure out, without actually finding the roots of a given quadratic equation, you can easily comment upon the roots of the given quadratic equation such that what kind of roots that given quadratic equation has. Either they are real roots. If they are real roots, they are real as well as equal or unequal. Suppose if they are not real, then why are they not real? So according to this, you can easily figure out the nature of the roots of quadratic equation. Let's have some examples and discuss about the nature of the roots of given quadratic equation. Okay. So now I have some equations and you will have to understand that each and every quadratic equation has roots, but you will have to conclude that that particular quadratic equation has real roots and equal roots or not, and real roots or unequal roots or not, as well as they are complex roots. Okay. For example, the first one is given as x square plus 7x plus 2 is equal to 0. x square plus 7x plus 2 is equal to 0. Now tell me about the nature of the roots of the given quadratic equation. You are not asked to find out the roots exactly. You are asked to find out the nature of the roots of given quadratic equation. So that when you are asked to figure out the nature of the roots of quadratic equation, you just find out the value of b square minus 4ac. That is the value of discriminant. So what is the discriminant of given quadratic equation? Of course, you can write the formula if you want. That is delta is equal to b square minus 4ac, right? Where the value of b is equal to 7. So 7 square minus 4 into a is going to be 1 and c is going to be 2. So which is equal to 7 square is 49 minus 4 2s are 8. Of course, 49 minus 8 is equal to 41 is obviously positive, so that we can call it as more than 0 number. Therefore, the value of delta is more than 0. Therefore, what kind of roots this quadratic equation has? Yes, it has real as well as unequal roots. So that you should write here, therefore, it has real and distinct roots, or real and unequal roots, or real and different roots. And for example, I am taking one more quadratic equation, that is 3x square minus x plus 7 is equal to 0. This is one more quadratic equation. So my question is just to comment upon the roots of this quadratic equation. What does it mean? You will have to find out the nature of the roots of this quadratic equation. For that, again you will have to find out the value of delta, which is equal to b square minus 4ac. So b square minus 4ac, which is equal to b is minus 1 whole square minus 4 times 3 times 7. Minus 1 whole square is equal to 1 minus 4 3s are 12. 12 7s are how much? 84. Then it is going to be negative 83. Of course, since it is negative number, can we conclude that this quadratic equation has non-real roots? Yes, of course, because this is a negative number. Therefore, delta less than 0. Since delta less than 0, it has non-real roots. Okay. So non-real roots, as well as if they are non-real roots, obviously they are distinct roots. See, out of all these discussions, we can conclude one thing here, that there is any quadratic equation which is in the form of ax square plus bx plus c is equal to 0, ax square plus bx plus c is equal to 0. Any quadratic equation, you can consider any quadratic equation irrespective of the sign of x square as well as the sign of x. I have x square minus 3x plus 1 is equal to 0, and I have x square minus 3x minus 1 is equal to 0. In these two quadratic equations, you can easily say that about second quadratic equation, x square minus 3x minus 1 is equal to 0, without actually finding the value of b square minus 4ac. You know how? In b square minus 4ac, if the sign of c is negative, then negative into negative is going to be positive. B is any real number, then square of any real number is going to be positive, otherwise 0. So there is no negativity in that. Therefore, b square is always greater than or equal to 0, if you could say, as well as a is always positive according to the given quadratic equation, and a is positive but c is negative, right? If a is positive, c is negative, then what about a into c? Positive into negative is obviously negative. So that a into c is negative. If a into c is negative, then obviously 4 into ac is also negative. 4 is being a positive number. So positive into negative is always negative. So what does it mean? B square is positive, 4ac is negative. Since 4ac is negative, what is negative 4ac? Negative of negative is going to be positive. It means greater than 0. Therefore, b square minus 4ac is always more than 0 when the value of c is less than 0 as well as a is more than 0. Please remember this condition. If the value of a is more than 0 and c is less than 0, irrespective of the sign of b, the given quadratic equation has always real roots. Maybe equal, may not be equal, that doesn't matter, but it has always real roots, never be imaginary. Got my point? If the value of c is smaller than 0, means if c is negative as well as a is positive, under these two conditions only, not for every single quadratic equation, right? So if c is less than 0 as well as a is greater than 0, then every quadratic equation under these two conditions has only real roots, right? So this is about the nature of the roots of quadratic equation, and we have some applications on this. Those applications are like, for example, you will be missing either coefficient of x square, otherwise coefficient of x, otherwise constant. For example, the given quadratic equation is if x square minus kx plus 3 is equal to 0, if x square minus kx plus 3 is equal to 0 has equal roots, then find the value of k. If it has equal roots, find the value of k. How do you answer this problem? See here, the key point is has equal roots. When the roots are said to be equal, then definitely you will have to think about nature of the roots of quadratic equation. So roots are said to be equal only when the value of the discriminant b square minus 4ac is equal to 0, then only the roots are said to be equal. Yes, we have a key point, then with that key point we can easily answer this problem. Since the roots are equal, right, since the roots are equal, delta is equal to b square minus 4ac is going to be 0, because it has equal roots. Please be very careful with the given condition, so that you substitute the value of a, b, c in this b square minus 4ac and equate with 0 and solve for whatever the unknown you want. So the value of b here is negative k, so negative k whole square minus 4 times a is going to be 1 and c is going to be 3, which is equal to 0, right? So minus k whole square is going to be k square, minus 4 into 1 into 3 is equal to 12, which is equal to 0. So k square is equal to 12, k square minus 12 equal to 0, then what is the value of k square? Yes, k square is equal to 12. Can you tell me what is the value of k now? Is the value of k is equal to root 12? No, you should not write that. So k is equal to plus or minus square root 12. Just now we discussed about this, right? So k is equal to plus or minus 12. So k is equal to plus or minus. Can you simplify the 12 further, because it is inside the square root? If you can factorize the 12, and if one of the factors of 12 is a square number, we can write it as a simplest form. That is going to be, the factors of 12 are 4 and 3, so that you can write it as 4 into 3. Now it can be written as square root of 4 into square root of 3. So square root of 4, yes, obviously that is 2, and square root of 3 is irreducible. So therefore the value of k is equal to plus or minus 2 root 3, right? So this way you can easily answer these kind of problems. So these are some applications on nature of the roots of quadratic equation. So let's look into one more problem which is similar to this, but you be very careful while answering this problem. That is,